Syawalul Mizan Putera Bin Ahmad, and my matrix number is 73854. Today I will show you my mini project, and this is the schematic diagram that has been given in ELIP. So based on the schematic diagram given, we can now find the total resistor, current and voltage. Firstly, we combine these two parallel resistors, which is R2 and R3, using the given formula, which is R1 times R2 over R1 plus R2. So when we combine the parallel resistor, which is R2 and R3, it will become like this. So we insert the formula given, and it will become R2 times R3 over R2 plus R3, and when we calculated it, it will give us 0.5 kilo ohm. From the combined two parallel resistor, we can now find the total resistor, which is using the series formula R1 plus R2 plus R3, where we can see that R1 is series to R23. Therefore, we are using the formula R1 plus R23, and when we calculate it, we will get 1.5 kilo ohm. Once we get the total resistor from the circuit, we can now continue to find the total voltage and total current by using the formula V equals to IR. From the circuit, we know that the voltage is 1.5 volt. So therefore, the total volt across the circuit is 1.5, and we need to find the total current. So we insert the formula V equals to IR, and we substitute all the value inside the formula, and we will get 1 milliampere for the total current. To find the current and voltage for each resistor, we need to refer to this circuit. Alright, so we know that in series, the current flow through all resistors is the same. So we are using this second figure to find the current for R1. So we know that the total current for this circuit is 1 milliampere. Therefore, the current for R1 and the current for the whole circuit is the same, which is equals to 1 milliampere. And from the current that we have found in resistor 1, we can now find the voltage for resistor 1 by using the formula V equals to IR, which is V1 equals to I1 times by R1. We all know that the current is 1 and the resistor is 1. Therefore, the value for voltage resistor 1 is 1 volt. Next, after we found the current and voltage for resistor 1, we need to find the current and voltage for resistor 2 and 3. And for parallel resistor, they have the same voltage. So all we gotta do is the total voltage in this circuit, which is 1.5 volt, minus the voltage for V1, and the answer will be 0.5 volt. Lastly, to find the current for R2 and R3, we are inserting the voltage that we have found, which is 0.5 volt, and insert it into the formula V equals to IR, and therefore we can find the current for I2 and I3, and which is I2 is 0.5 milliampere and current for I3 is 0.5 milliamp. Firstly, we measure the voltage for the battery, which will be, since it's negative, so it's deposit rate, which is 1.60. Check the value for the resistor. We change it to 20k. Alright, and then measure it. 0.97 kilo ohm. For the second resistor, we check the value again. We will get the same, 0.97. And for the last resistor, we get 0.96 kilo ohm. Firstly, we set up all the resistor based on the figure given, and the battery, we connect the wire and we can connect them with other jump wire. Connect the positive side of the battery at the positive side over here, the pink color line. Set that here. And for the black wire, we connect it to the blue, which is the negative side. Now we connect the wire, which is over here. Connect it, which is to here. Okay. The resistor 3 is parallel to resistor 2, so we connect it in front of here. Okay, and then we connect it to resistor 2 in front of here. Okay, now for this wire, we connect it here, and then in here. Yeah. For this one, we connect to the first resistor in front of here. And connect it here to the positive side, to the negative side. Okay, it's in. Now, to measure the total voltage, we need an extra wire and connect it in the middle between the resistor 2, 3. And the other wire to the resistor 1, near the resistor 1. Okay, now since all the wire is connected, we can now measure the total voltage of this circuit. Now to calculate the total voltage, we set up the multimeter mode to the voltage side, which is the 20 volt, and then we connect these two wires which we just connected just now from the circuit, and we measure the total voltage. Okay, the black one is for the okay. So as you can see, the total voltage is around 1.59. Yeah, 1.59 volt. To calculate the partial voltage for each resistor, we need to connect the wires, okay, to the legs of the resistor number 1 first, which I'll get 1.06 volt. 1.06 volt. And next is for the resistor 2 and 3. We know that in parallel they have the same voltage, so I only measure for one resistor, so I get around 0.53 volt. Okay, so now I know that So that now I know that R2 and R3 are parallel, so the same voltage, which is 0.53 volt. To measure the total current of this circuit, firstly we change the mode of the multimeter from voltage to ampere, and then to find the total current of the whole circuit, we break the circuit first and rearrange it, and then we can calculate the total current. We can measure the total current, which I get which I'll get 0.10 ampere. Okay, to measure the current for resistor 1, with the red wire we put it on the leg of the resistor 1, and for the black wire we put it on the orange wire, and I'll get around 0.10. To find the current for resistor 2, we add another jump wire near the leg of the resistor 1. Okay, and then you take the leg of the resistor and the jump wire, connect it, and we will get 0.05 milliampere. Now to find the current for resistor 3, we are doing the same like how we did to resistor 2. We break it and then we put a jumper near one of the leg. Now we can measure the current for resistor 3, which I will get 0.05 milliampere. Okay. At the end of the experiment, we can see that the value has been obtained is slightly different. From theoretical values, the voltage in the battery was 1.5 volt, while on measured values, it was 1.6 volt. This is because I'm using a new battery which still consists of a lot of energy inside it. Apart from that, the current value from the both table is not changing. In my opinion, the difference in voltage and resistor value may affected by some factors that contribute to experimental values being different from actual values, which are human errors, procedural errors, and environmental errors.